Okay, we're going to look at how to put the puzzle pieces together now. We made a block, and we are going to use that block to make a puzzle piece by making what's called an assembly. Now, before we start, we have to go to Projects and make sure we're in the Block Puzzle Project folder, which we are. You can see the check mark by the block. We'll say Done. And now we're going to make a new file. And the new file is called a standard IAM. Now we come down here, we see that here is our standard IPT. That's what we use to make parts, but we're not making parts. We're making an assembly of parts. So we want to come down here where it says standard IAM. That stands for Inventor Assembly File. So we'll click on that one, and we'll wait a second here as it comes up. Now what you're going to notice is that it's not like an IPT where it starts off in a sketch. You're not going to make a sketch in the assembly file. What you're going to do is you're going to bring in parts to make an assembly. And when you bring the parts in, and of course we only have one part, right? We have a block. And the block, in our case now, we have 4 blocks because the part I'm going to make is the same part that we worked on in the sketch mode, which is that one sample part. You saw it when we worked on the sketches, and you saw it when we talked about the puzzle pieces. So we're going to make that part. I don't know. Do I have to select create here? Maybe I do. Yeah, it looks like I had to select create. I think. Here we go. Okay. I guess double clicking isn't enough. This is the first time I've made an assembly file with this program. This is the new program. This is Autodesk Inventor 13. It's the first year we've been using it. And sometimes the first time you use the program, it has to go through a series of whatever it's doing. All right, so you can see here now that we have our assembly window. This looks a little bit different up here. It looks a lot different. Here's our assembly window. And what we need to do is we need to bring the parts in that we want to use in our assembly. Now, because we're in the block puzzle project, when I go into the folder to place a part, it's going to automatically take me to the folder that's called block. And what is in the block assembly folder? What is in the block project folder? A block. So let's click over here on place. This is where you put the parts in. So I'm going to select place, and it's going to open up a window, and it's going to show me the available parts that I can put in. And we only have this block.ipt. There's our block part. We're going to select it, and we're going to select open. Now, I'm going to, it's giving me an error message here. You should not see this unless you've loaded the educational version of the software like I have. Let's go ahead and just say yes to that. Now you'll notice here that there is one block that comes into view. I'm going to use my cursor or my mouse and scroll out. You can see now it's giving me the option of putting more than one part in. It always does this when you bring a part in with the assembly. So I need 4 blocks. So there's one there, 2, 3, 4. And when I'm done placing my blocks, I'm going to right click and I'm going to select OK. And now you can see that I have 4 blocks that I'm going to be using in my assembly because my part, the puzzle part that I'm making, has 4 blocks in it. Remember, each one of your puzzle pieces has to have 4 to 7 blocks. Okay, so I want to divert your attention over here to the browser bar, and I want you to look closely at block number 1 here. They're all called block, but we have 4 instances of the same part, block 1, 2, 3, and 4. Look at block 1, how it has this little tack symbol. That's called grounded. What grounded means is that when you bring a part in for the first time, it's going to automatically put a ground constraint. Now, what a constraint is when you force the part to be bound in a particular way. If we ground the part, it means that it cannot move. So if I come over here to this part and I try to move it by left clicking on it and then dragging it around, I can't because it's grounded. If I grab block 2 and do the same thing, I can move it around anywhere I want to move it. Same thing with block 3 and 4. I can move them freely. Now, you always want to have one of your parts grounded in your assembly mode. In this case, this block is fine. We can go ahead and use this. So this block is grounded, and what that means is I'm going to be using this block to build my assembly from. So in order to get these blocks to be exactly where I want them to be, I have to use what are called constraints. Okay, and I want my block to look like that. But I need all of these to be exactly constrained together. So the way we do that is we come up here to the ribbon, and you can see the word here where it says constrain. And you know, this is a good tip too. Whenever you have a question about what these particular commands are, if you leave your cursor over the command, just leave it there, it will come up with a definition and sometimes an animation. Now look at this, it's showing us a little animation about how constraints work. Do you see that? It's showing you how to apply the constraint. So you can always come to the animation and get some ideas about how to use the various tools on the toolbar, on the ribbon. So we're going to click on constraint, and there are two constraints that we're going to be using throughout this project. It's called the mate constraint and the flush constraint. Now, if you look closely at the picture, you'll see a mate constraint takes two faces and mates them together as if you were gluing the two surfaces. So imagine you're taking two surfaces and gluing them together. Well, that's what a mate constraint does. So that's what we want to use initially. So if we come over here to our first block and we select this face, and you can notice you can select faces, edges, or even points. So I'm going to select this face here. I'm going to click on it. Now, because this block, all the faces are exactly the same, it doesn't matter which face I select, but just for the purposes of showing you this command here, this tool, I really want, if my blocks were orientated in this fashion, I would want to mate this face with the face that's on the inside that I can't see right now. So what I have to do is rotate this around so I could see that face. I have to right click and say OK, and now I can select that face that I want to mate together. Now watch what happens when I select that. It goes together and it's mated. So if I click, and now you always have to click apply. If I say cancel or OK, it's not going to be on there. So I'm going to click apply, and now I can say cancel. And if I rotate this around, what's happened is that this part, this block, is constrained to that face. So the inside face of the block is constrained with a mate constraint. It's mated to the face here of this block. So no matter how I move this block, it looks like I'm moving it away from the face, but when I turn it sideways to see those two faces, you can see that they are indeed lined up. Do you see that? So that's called a mate constraint, and I've constrained those faces. Now, I'm not done because obviously I can still move this part. So what I'm going to do now is I'm going to use what's called a flush constraint. So we come up here to constraint. Flush constraint is the one next to it. And what flush does, if you look at the two arrows, it takes two faces and lines them up so they're on the same plane, so that they're lined up. It doesn't put it face to face, but it puts the faces on the same plane. So I'm going to select the top face of block number 1 and the top face of block number 2, and watch what happens. It brings it in line with that face. I'm going to click apply. And now, how would I finish constraining these two blocks? Well, I can do a mate constraint of not the faces, but I could mate these lines. I could mate these edges here. But I think it's because I already have the flush constraint selected, I can flush or bring along the same plane these two faces, this one here and this one here. And if I apply it, and now you can see that these two blocks are completely constrained to each other. This one's grounded, so it can't move, and now this one is constrained completely to this block, so it can't move either. So I'm going to come back to this block, and I want to put this block next to it, so constrain. And I'm going to leave the mate constraint. I'll mate this face. And now I don't really need that inside face because all of these faces are exactly the same, so I'm just going to click on this face. And you can see that it mates that face. I'll apply it, and then I'm going to do a flush constraint of the tops. I'll flush those, apply, and I'll flush the sides again. and I'll apply those. Okay, now I'm going to do a mate constraint of this face here with this face. I'll apply it. And you'll notice now, because I'm going to put this block in the middle, that I can do a flush constraint of these two faces. I can apply that. But now there's nothing else to flush up. So what I'm going to do instead of flushing is I'm going to mate this line, this edge, with this edge here. So we'll use the mate constraint. I'm going to select this line, and I'm going to mate it to this line. And it makes those two lines collinear and puts it exactly where I want it. I'll apply it, and voila, I have my first puzzle piece. And that's how we make a puzzle piece. Now I'm going to save that using iPro Save, and I want to save this as Assembly 1 under the block folder, which it's always going to go to, Assembly 1, and I'll save it. And then you want to close this out. And the reason you want to close it is because we're going to be making each puzzle piece, all 5 of them, in 5 separate files. So I would go to New, I would select Standard IAM again, and then I would make my second puzzle piece, and I would save it as Assembly 2. I would close it, and I would continue the process until I had 5 puzzle pieces in 5 separate folders. I want you to give that a try. Take your 5 pieces that you've made and make individual assembly files for each one of them, and save them subassembly Assembly 1, Assembly 2, Assembly 3, Assembly 4, Assembly 5.